I'm Yun Peng, a PhD student from SCAR Group at UC Irvine. Today I'm going to present our work titled Infrastructure-Aided Defense for Autonomous Driving Systems, Opportunities and Challenges. This is a joint work from our group and our collaborators at Perceptive Inc. Recently, there is a new trend of designing autonomous driving systems called infrastructure-aided autonomous driving. It makes use of roadside sensors and communication units to assist autonomous driving systems. There are many companies working on this technology. For example, Baidu is testing intersections with such infrastructures in several cities. They even showcase L4 autonomous driving capability with only infrastructure side sensing. So robotics proposes to use sensors embedded in surrounding infrastructures for L5 autonomous driving. With this new trend of designing autonomous driving systems, it's very important for us to explore how it may influence autonomous driving security. Based on this, we propose infrastructure-aided autonomous driving defense. We call it IA2D2. This is a new AD security design space leveraging infrastructure-side support. We first comprehensively surveyed existing AD attacks and classified all 52 of them into 3 categories. Attacks to perception of infrastructure authoritative information, attacks to perception of dynamic raw objects, and also attacks to localization. We found that with the help from the infrastructure, all 3 of them can be defended against. The infrastructure can actively send the information to the vehicles, like stop signs and traffic lights ahead. And also, the infrastructure can help localize on-road objects and also help localize vehicles. But to defend against all these attacks, different capabilities are required on the infrastructure. To defend against A1 attacks, the infrastructure is required to have basic communication capabilities. To defend against A2 attacks, the infrastructure is required to locate and perceive on-road objects and then report them in time. To defend against A3 attacks, the infrastructure is required to locate vehicles and send timely updates. But on the other hand, we also noticed that IA2D2 is faced with some challenges. For example, to defend against A2 and A3 attacks, the infrastructure is required to accurately locate on-road objects. We actually collect LiDAR point cloud data from a road with real IAD deployment for testing purpose. We tried 3 LiDAR object detection models, which are a segmentation model used on Apollo 5, Pixar from Uber, and also point pillars. We list all the errors from these 3 models in this graph. And we can see that only point pillars is close to meet the requirements I mentioned before. And also, IA2D2 may also introduce some adaptive attacks. For example, the attacker may launch simultaneous attacks to both the infrastructure side perception and also on-vehicle perception, which may evade fusion-based defense. And also, since the infrastructure side sensors are fixed, they may be more vulnerable to attacks that require aiming. Therefore, the infrastructure may become the weaker link of the system. What's more, the communication between the infrastructure and the vehicles may introduce possibilities of cyber attacks. To sum up, we are the first to explore infrastructure-aided autonomous driving defense. We call it IA2D2. This is a new AD security design space leveraging infrastructure-side support. We found that IA2D2 provides new defense opportunities for all 3 categories of existing AD attacks. And we also found some security design challenges coming with it. This is still a work in progress, and we are open for any opinions, criticisms, and suggestions. Thank you. That's all.